Okay, theoretically, that's recording, I think. So we'll see. If not, I'll try to do it again next period. So you have this equation that describes your velocity. Oh yeah, the format, remember, is the same. You have your observations, investigation, like on the bottom, right? And then your log builds as you go. Remember, your log needs to be dated as you go. I want to be able to follow by date what you were doing in your groups, right? Then below your investigation or somewhere after that could be a couple pages, right? Because maybe you had some discussion, a lot of discussion, whatever. Then you could have your procedure, like you were supposed to do your own procedure. Then, was that a homework? I don't think it was homework. Yeah, so you have your procedure on there, then you have your group procedure on there. You should have a data table on there. So this is all building towards the front of your document. And maybe some calculations, like you were trying, testing calculations. Keep all of that on there, right? If somebody is like, oh, I think you do it like this, and they write it down, but it's wrong, don't erase it. Just like make a note, okay, this is wrong because of this, and then do it again, right? Because you want to be able to catch the entire thought process. And then finally, on the very top page, we have our abstract, right? The abstract, and of course, this is typed. This is typed, but don't worry, if you didn't type it before, I didn't write a big giant F and then throw it, whatever. But it's typed so that you have your abstract there. Then you have your quantitative. Now, what error analysis? What do we have to calculate in this lab? Yeah, there's going to be instrumental uncertainty. There's also going to be experimental uncertainty. Okay? Do you do percent error this time? Yeah, I didn't calibrate anything to determine, I didn't use anything to determine an actual initial velocity. So we're fine. I think what will happen is we'll discover some people will have dramatically different ones. But I think your calculations should have come somewhere out around, what, like 5 or 6? Maybe around 6 plus or minus meters per second? Or did you not calculate yet? Okay. Well, anyway, so we're doing an instrumental and an experimental uncertainty, and then your qualitative, in which you discuss, is this reasonable? Why was there error here? How would you correct that error? Okay, and these things have to be specific, right? Like, in this part of the experiment, in our procedure, this was the thing that caused this error. If I can do this again, I'm going to change it as such. Any questions on the components of this? All right, so let's talk real quick about this. Behind this page, you are going to have a spreadsheet page. Okay, so last time we had a graph, right? This time we're going to have a spreadsheet page. And on that spreadsheet page, I want to see your calculations. Okay, you're going to do the calculations for the lab in Excel. How do you do that? Well, obviously you're going to make one of these columns like X. And really, that's the only thing you measure, right? Because theta, you set it. I guess some of you will have to do multiples for thetas, because some people did multiple thetas. But if you did like 10 trials all with one theta, then you're just going to have all of your x's here. And if I do that, then I would say this to get x, I'm going to say equals SQRT, open parentheses, and then whatever that is. Like, let's say, for example, that's B. That's going to be like B1, asterisk, whatever, 9.8, front slash, then we're going to go sine, and then we're going to go radians with an S, and then put your angle in there. Unless you want to put your radians in there. Do you get what I'm saying? Like, you could do this. Let's say, for example, you chose 45 degrees. You could just do pi divided by 4. Okay? Yeah, I guess I didn't include the 2. Sorry about that. Okay, so this is going to be sine of 2 times pi. Because I believe you have to do this and then do that, because that means give me the value of pi. So then you're dividing by 4, multiplying by 2, so I guess technically you could just say divide by 2, but whatever. If you don't do that, if you have your angle in degrees, then you should be able to do sine of 2 times radians, and then put whatever, like say 45. And then close your bracket. Now, this is off the top of my head. We're going to find out in a few seconds if this is right. we're going to try it and see. So our mileage may vary, and I may have to sort of apologize for mistakes there. So let's go ahead and take a look. If we go here and I say this is x, and I don't know, what was that? Actually, let me zoom this in so we can see. Okay. How far was x? Like 3 meters? Okay, so I did my 5 trials, and I got these 5 things. So I want this to be v. So I go down here, and I say equals SQ, and notice it does that very nicely and finish it for you. Oh yeah, it was B1, so it's going to be B, sorry, that's actually B3, times 9.8 front slash, oops, and it was sine radians, and let's say 45, let's say 40. Oops. Yeah. Ah, crap. Okay, now I gotta fix it. Nice. Okay. Why is this answer stupid?
Because there's so many decimal places.
Yeah, because it's idiotic with the number of sig figs. So remember, what is the magic number? No, not 2. The magic number, if you're not sure, is 3. Okay, if you use 3, it usually looks scientifically appropriate. Okay, obviously here, because it rounded off the 3, or it put the 3.0 to 3, then you would, this is technically 2 significant figures, right? So technically this answer should be rounded off to 2, like that. But just use the magic number of 3. Now, you realize this is rounding, right? So it's got the entire value inside there. It's just showing you this many. All right, now, here's the fun part. You have to show me your calculation. So if I take this cell and copy it and paste it up here, like this, double tap on it, and if I get rid of that equal sign, I have a perfect copy of what I did down there. Does that make sense? This is how you show me what you did. And I think we were actually right on the money. Square root B1 asterisk 9.8 divided by open parens sine open parens 2, and then this radians converts this to radians because the sine function in Excel only does radians. You can't switch it to degrees. It has to be in radians. So I think I could have put pi over whatever. So if you did 45, then you could just do pi over whatever, but yeah. Oh, that's interesting. There's an easier way to do that, depending on how you measure. Let's think about this for a second. What is sine? Say this is your shooter, and then this is A, that's B, and that's C, right? Right, does the sine of theta Does everyone see it should be C over A?
Yeah.
So you could just literally, could you do that? No, because you have to multiply by 2. Ah, darn. If this was just sine of this angle, you could just plug in this fraction. You could literally take your measurements and plug it in. You wouldn't even need to use sine function. But we have to do the double, so. I mean, if you have all 3 sides of the triangle, then sine 2 theta is actually 2 sine theta cos theta, remember that? So you could actually plug that in, and you would get something like, for this, instead of sine 2 theta, you get 2 sine theta cos theta. If that's your triangle, A, B, C, you get 2 times C over A times B over A. And that's literally with the measurements, which is kind of a neat thing.
So all 3 sides you do that?
Yeah, if you have all 3 sides, you can just do this. You don't even need to use the sine function. But whatever you want to do. If you already calculated your angles, then don't do this. It was just a little mathematical, interesting point that I found. All right, anyways, so you must do this. Anytime you do a calculation in Excel, you must show me your calculation. If you don't show it to me, then what I'm assuming is that you just wrote it in. You did it on your TI and you plugged it in, which doesn't get you any credit, okay? Then, of course, I just copy this down, and I get all my data. Yeah, that's very neat. Especially if you, I think some people did like 20 trials or something. How many?
37.
37? And that's gonna be very helpful for you.
And so you just, can you do it again? You just drag down the...
Yeah, let me just get rid of that. So if you look at Excel, you see there's the fat plus. That means select the whole cell. Select the contents of the cell. The hand means move the cell. So if I do that, it moves it over here. But you'll notice it doesn't change the references. So it's going to stay the same. Okay? Then if you move it on there, it's a little black plus. That one means copy wherever you drag. So if I do that and click and drag, boom, it copies the formula down, which makes life much easier. Okay, and then probably what you should do, just because I should show you this, give me an equals average, and then just select this. Oops, just kidding. I have to put the, I think if I go down, will it do it? No, we have to put the parentheses. If I would put the parentheses automatically, that's strange. So I do that, hit boom, and there's my average. Boom.
So you put equals and there's like a lot of math.
Now, see, why can't Calvin see it? Because it's hidden. So what do I have to do? Yeah, I have to show you. So I'm going to copy this over and delete the equal sign. Boom. Okay, and then something that we'll use later as well, which we need to get used to, is STD. Well, you should never get used to STDs. So, oh, okay, that's why. So STDEV, standard deviation, and then I just selected the right formula, and then it popped in the appropriate parentheses, and then boom. Okay, so standard deviation, do we know what this is?
Like, how to spread out this.
Any stats people like to explain it for us?
Is it spread out this and data?
What's that, Manny? Okay, yeah, and Eric said that too. It's a spread outedness. I mean, it's, that's a reasonable
It's a
term.
better concept.
Yeah, I mean, that's a reasonable way to explain it. It's the easiest way to explain to give people a grip on what they're talking about. Let me show you what I mean. If this was height, okay, at this school, no, that's not height. Oh, sorry, just kidding. This is going to be, I don't know, let's say this is meters. And then here we have people from like 0 to 1 meters. Then we have like 1 to 1.5. Then we have 1.5 to 2. Where are most of the people in this school? And then we have like 2 to 2.5. Where would you think most of the people in this school are going to be? I'm guessing most people are going to be. Oh, most people are going to be here. Then there will be a few here. There will be none here. There might be like 1 or 2 there. Wait, sorry, that's not meters. This is the number. That's the number of people. So this you know, like this might be whatever, 1,200, and this might be like 500, and this might be 100, or something, something like that. Right. So you see how this makes this kind of thing like that. This is called like the data distribution, the normal distribution. If you did this same thing, but instead if I did every like 1/10 of a meter, so I had a bunch of small, like if you measure things that have large sample size, they always make this bell curve. See how it looks like a bell? Ding dong, ding dong. Looks like a bell, right? Okay. Now, when you look at the bell curve, have you ever heard, you know, people say, is the test curved, right? You've said that before. What you really need to understand when you ask that question is if a test is curved, let's say that this is the distribution of the test. Okay? Oh, yeah, the other thing. The standard deviation measures the squattiness of this hill. A very, very low standard deviation looks like this. And what that means is most of the data is very close together. A very big standard deviation might look like, I don't know, something. Right? These 3 things can all have the same mean, but they have very different standard deviations. And what they mean, the green one, the data is more spread out. There's more people who have like who are short and tall. The red one means most people are right around one size. Okay, but the thing to remember is that in college, if you want a curve, it doesn't mean what you maybe think it means. If you curve the data, let's say you have the test data goes like this. This could be theoretically like 90%. And if that's 90%, the average, that means that's a C. So yeah, you have to be careful. That's the way college professors usually graph or do this is it's something like this. And they'll look at it and go, oh, okay, this is the biggest grouping. I'm gonna make that C. These are A's. Oh, sorry, these are B's, these are A's. Those are D's, and those are F's. Like they just look at how the data groups itself, and then they call it that. All right. May have just crashed. No? Okay, we're good. All right, any questions on this part? So I want to see you calculate V in Excel. I want you to show me the formula. I want you to find the average, do this, and then you can also find the uncertainties here as well. Right? Yeah.
So for the blue key one, is that indicating where the number is and you want to put that into it?
Yeah, see if I look here, see it's going from B3. It's looking back to that cell. That's the beauty of Excel, right? You give it a formula, and then so I give him a formula, and what he will do is go over here and get something from him, and go back there and get something from you, put it together, and make something. That's the beauty of Excel. So these little blue things indicate where it's from. What?
What is the SQRT? Do you just type that in and then choose it?
Yeah, like it'll, as you type in SQ, it'll like start showing it underneath. And just arrow down to square root, hit enter, and it'll do square root with the parentheses. And then you just start typing the formula inside. Yeah.
Do you have to rewrite every equation so that each B?
Yeah, in order to do calculations, you have to rewrite the equation.
So for B1 to B3?
But you saw how I did it, right?
Yeah.
I just went whoop, whoop, and it did it.
No, I mean, do we have to copy each each ease out to give the equation next to it, or
No, it's all the same equation.
okay,
Right.
same one.
You see how this one looks exactly like that one? If I go here, that looks exactly like that one.
So you don't have to write that.
No, the reason I did this once was so that you could see. Okay, but remember, you need to do uncertainty, experimental uncertainty, and instrumental uncertainty there. But those are easy, like divides or whatever. So that should be fine. Questions? All right, very good.